Okay, audio check. 1, 2, 3. Sounds good. So I guess we can get started. All right. Oh, goodness gracious me. Whew. Sorry. Feel a little drowsy today. Up late last night. Ate a ton of donuts yesterday. Gonna continue that right on through the stream. The donut eating, not the being tired. Well, maybe being tired, but not staying up late. There we go. And yeah, so I need to switch over to. We're just gonna kill this Emacs session and fire up a new one. Close extra things I've got open. Okay, let's set the size for streaming, and we're gonna open up our to-do list and the old journal. Okay. All right. Hey, JTL. Yeah, carb hangover. I know my run this morning was that was tough. I did a shorter distance but faster pace run. Mostly because I was running out of time, but it was killing me. And I'm just gonna keep that. The best way to treat a hangover is to give more, right? So I'm just gonna keep eating donuts right here on stream. See if that fixes the problem. Oh, how's your carb hangover going? Same mood. Yeah, it's probably not going to start getting better until next week. I think we'll probably run out of donuts today, but yeah, it's not going to improve until probably starting Sunday. Hair of the dog, exactly. Hair of the dog in terms of carbs and donuts. That's still, yep. They were good donuts though. All right. Now, finish yourself for breakfast and lunch. I thought you said they were going to last you through to Sunday, maybe. Normally I'd use my hands to eat my donuts, but I've got a keyboard here. I like to keep it sticky free if I can. It's not even a very good keyboard, but who wants to go buy more keyboards? Is it just me or is keyboard shopping really depressing? Like, all I want is a very simple model, just works. Everybody's got all these fancy features. Yeah, apparently not. Yep. So good. Okay, today's plan. 11. Wow, welcome to November, everybody. We've got too many combinations of build options now, and I can't test them all efficiently manually anymore. Therefore, we are going to write a tool that makes all the combinations, which I guess means we need the list of our performance switches, and we just want to make sure that they just work. We got 3 of these, 2 of these, 3 of these done. And I want automated testing before I start to go into the go-to. This is its whole own special ball of wax. Those two need to be combined actually only with those 2 options. Interesting. So maybe this isn't too bad. Okay, then our different processing and our different helper methods. Those are all the different things. They can all be combined in any which way, and that's too hard to test. Do you prefer the chiclet type keyboards or the old school clickety clackety type keyboards with mechanical switches? I don't. What I usually do is I buy the cheapest keyboard I can, because if I buy something expensive and then the keys start to fail, which I've done before, I just get mad. So I buy something cheap, I know it's gonna break, and I don't feel bad about it. So it's probably the cheap crap chiclet keyboards right now. I should take keyboard selection a little bit more seriously, but I just can't talk myself into getting enthused about looking over keyboard features. What I want is for somebody else to have tried out a whole bunch of keyboards and tell me which one's the best one. Unfortunately, one of the main features I'm looking for is lifespan. The only way to know if a key is going to last for 1,000,000 strokes is to sit there and use a keyboard for years. So, yeah, I don't know. I treat keyboards like I treat my watch. I know I'm going to lose it. I know I'm going to bust it. Just buy something cheap that does what I need. And don't worry too much about it. I will spend a little bit more for a mouse, but not much more. Like, I don't buy the cheapest bargain bin mice. There's a big difference in button life cycle on cheap mice. But again, I want somebody that's used a ton of mice and can tell me something that doesn't cost $200 that just works. That would be wonderful. Okay. So we have a plan. When we go through each test, we need to compile and make sure that the output of that is correct. Execute the new binary file and verify the execution completes successfully, and then verify that the output of the test itself is correct. That's the short answer. As far as file reading, this is fine, but for function binding, this only combines with 2 other things. So I actually think we can run that, because it's basically, instead of 2 combinations, it's 4 combinations instead of a full permutational explosion of 2 more. That doesn't make any sense. Let me explain. I want to test each of these dispatch methods, but they need to work for these 2 options. So normally in combinatorics, you would multiply those, right? And say there are 3 times 2 times everything else, right? Because there are 3 dispatch methods currently supported and 2 function pointer methods currently supported. But this only applies to these 2 and won't apply to the go-to. So instead of adding something like 4 times 2, it's actually just each of these has 2 options. So it looks more like this. So it's actually 1, 2, 3, 4, 5, 6 instead of 4 times 2. And we don't even support go-to yet. We want to test everything else first. So maybe we can actually iterate that in all the permutations we're going to do. So we need a tool, we need a script. We're just going to do it in Python. I don't know if I want a class at all or not. We'll start with that one and add it if we feel like it. So part 1 of this fun adventure is we need all the permutations. Okay. Okay. So there we go. We have to test all these combinations except it looks like this and like that. And like that. There we go. And consideration. VFA dispatch. How do we process things? And helpers. Okay. All right. Okay, and then we're going to search for a quote, -D, search for another quote, F4, 1. So these are all of our defines. At the heart of all of this is a bunch of loops for now, file IO isn't really bound to all the other things in the same way. That one we can kind of separate out and not do in the same way. Oh, well, let's just step it out the same way. File IO in file IO. Let's call this defines for file IO, defines for text generation, defines for that. For let's see here, text editor in define text generation for dispatch in def dfa dispatch for process for proc in define process and for helper in defines for our helper function subroutines or whatever you want to call them. And this is going to give us one of our combinations. Now we've already simplified the pointer lambda distinction. So we've got 3 times 2 times 5 times 2 times 2. Let's just keep a little running tally here. Times 3, 2, 5, 2, and 2. 120 combinations. So we're going to have to build and test 120 times. This is why we're doing this script. Because we're going to add one more here eventually. So that'll be 144 eventually. But I don't think we need to. Because I think one thing we can do is separate this one out and remove a factor of 3. File IO equals index equals 0. We're going to start with that. We'll get fancier in a minute. Donuts are so good. Then inside the final loop, we're going to say file IO equals file IO index file IO index plus equals 1. So we're just going to rotate through because file IO is slightly separated from the other things. Hey, LP Kangaroo 100, welcome to the stream. Thanks for the follow. Let me know if you have any questions about the project. I can give you the full rundown, but I'll give you a short rundown here while we're sitting. We are building a compiler from scratch, literally nothing from a library. And the stages were the stages of a compiler are you take some text document called code, you put it into a tokenizer, and out comes a list of tokens. So like words, syntactical symbols, like in English, English words, comma, period, question mark, exclamation mark. You put those list of tokens into a parser, and out comes a syntax tree, which is basically the structure. So let's see here. If we have text of 1 plus 2, you might get a list of tokens out that looks something like 1 and 2. When you, oh, and plus, I forgot the plus. Plus and 2. When you get to the syntax tree, what you'll probably get is something that looks like plus of course it does that. Oh, come on. And then you'll get your 1 and your 2 as children of the plus element. So basically it adds structure to the tokens. It says these are the order of operation, precedences, and here's how things hang together. So this is like the grammar structure, right? Subject, noun, verb. That's kind of what the parser does. After which we go to semantic analysis. And that tells you if there's any errors, and a more complete tree, blah, blah, blah. After which things happen, right? It all kind of gets a little fuzzy after the semantic analysis step. But we are still on the tokenizer because we're not writing a tokenizer. What we're writing is a tokenizer generator, which takes in a configuration of some sort, which I'll point you to here in a minute. So let's see here, maybe V. And it's going to output our tokenizer for us. So our config might look something like test.v tokenizer, like this, where we have a name of a token, the actions to take for that token. So X means discard, L means count it as a new line, K means keep. We can get fancier later, but this is a good start. And then a regular expression to describe what types of text becomes this token. So one thing that's a little bit different about ours is we do alpha, numerics, etc. We also support full UTF-8 regular expressions. So that's a Cyrillic alphabet and a Greek alphabet, fully supported right out of the gate correctly. And because of that, we can also support this \s is normally like a space and a tab. We can also handle non-breaking spaces correctly without any more fighting with the regular expressions ourselves. So this is where we're at. We're at writing the code for the tokenizer generator, which will generate our tokenizer for us. Yeah, so that's where we're at. If you want more details, I'm happy to dive in and give lots of examples. What are you compiling? Your own language, or are you compiling an existing language? This is sick, by the way. Oh, thanks. We're still way back in the tokenizer area. We're not near the language part. It'll be my own language. Probably just a toy language to exercise all the system and play with some different programming ideas I have. But that's all quite a ways in the way in the future, because there are 2 or 3 special ideas I have about tokenizer generators that nobody else I've seen has done. So, but yeah, in the meantime, we're gonna test it against like JSON parsers, that kind of thing. We'll test it against all kinds of things, configuration files, whatever we feel like to test the system. Yeah. So our tokenizer generator is going to do it by deterministic finite automata. It's not going to be a backtracking system, forward only. And yeah. So if you have any questions, again, let me know. I'm happy to dive into details at any point. Otherwise, I just kind of code stream of consciousness and talk while I go. For today's task, let me pull this up. Performance switches. So every time I come to a point where I can choose to do things in different ways, I put in a compile flag. So, for example, file reading we can either use the system call, the library call, or modern C++ calls, right? We can iterate through the text file using an actual iterator implementation, or we can just walk through the indices ourselves, right? We can dispatch our DFA states in multiple ways. And this combination of possible things that we can do is huge, right? So we were just grinding through that in our this thing, right? So right now we have 120 permutations of build options, right? And we're slowly trying to simplify that down. I think we got it down to being able to test 40 combinations and have a reasonable expectation that we've covered all of our use cases. And that's what we're doing today, is we're going to automate testing so I can make code changes and make sure that I'm not breaking things in another part that I'm not aware of. This is a bad way to do it. If you're going to write a programming language, don't write your Tokenizer Generator. I mean, you can if you want to. I'm not going to say don't, but it's not a good way. A tokenizer is very simple. All it is a loop, and then when you get a character, you look at it and decide where to go next. If it's a number, you're like, oh, go parse numbers, and if you hit a decimal point, it's like, oh, this is a float. It's not complicated. This is more for my fun than the right way to do things. And I kind of like that whole DFA, deterministic finite automata way of playing with text. It's kind of fun. So just I'll throw out the standard caveats. So yeah, let me know if you have any questions. We already have the DFAs working for a lot of the cases. I need to test all of our different build options because it's quite a few. So yeah, welcome to the stream. Since you're here, I also have a Discord channel, which I will put in the chat in case you want to get notifications when I go online. So Friday we do compiler day, and then Monday through Thursday is a game with no game engine. So yeah, welcome aboard. Ask questions, make comments, tell me better ways to do things. I'm open to all things. So this is the heart of our testing, is we're going to generate every permutation of build option this way, which should be 40 compile operations. So we might as well just print them out, right? Yeah, let's just print them out real quick. Print build defines, and we're just gonna cheat like crazy. We're just gonna say take the list. So also just to show you, like, we're doing a little bit of Python today. We don't do much Python on this screen except for like tooling. So if you want to know what kind of things we're outputting, vv test parser is kind of what we're looking at. We have some helper functions for dealing with the characters, UTF-8 characters, our string references, the text buffer. Then it gets interesting about the tokenizer stage, which is here. This is, like I said, those pound defines. If we're doing our helper functions as macros, here's what we do. And inside of that, if we're doing a batch process, this is what it looks like. And if we're doing function pointers as lambdas, so there's a lot of code in here that's duplicated and useless, and it doesn't matter because we're doing all these combinations. This 2300 line file we emitted doesn't really matter. We're going to get all the way to the end to where we can run large batches of tokenizer tests, and then we'll performance test each of these combinations, and then we'll delete all the dead branches. This is for fun and to know for sure 100% exactly how much these things contribute to our total runtime. So that's what we're doing today. Build defines. Okay, so we have our text iter, our dispatch, our proc, our helper, and our file IO, and that's all going to be joined by spaces. That's kind of the start of it. Somewhere, let's see here. Layout math. There we go. I just want to steal my shebang in here. Okay. Oh, we don't have shell open. What is wrong with us? Chmod plus x test permutations dot py. Oh, if file IO index is greater than or equal to the length of our definition town defines for file IO index equals 0. Boom. There we go. That should be 40 combinations, which we can even count if we compare 2 count equals 0. To D, this will be count. Count plus equals 1. We might as well start count at 1, right? Boom. All right, we got our 40 combination. Yep, that looks about right. Cool, cool. All right. That's the basic premise here. So in our journal, we said we need to compile. So let's do this. Define build let's see here, next. What do I want to call it? Let's not be fancy. Build permutations. Do all this, and instead of a print, all we really need is that thing there, the join. Build.depend. Turn result. Okay. For build in build permutations. There we go. Simplify, runs, still looks good. Okay. Oh, goodness. Part 1. Okay. We need to compile a build. execute. Okay. We need I'm going to steal some code from another project. Do I remember where I put it? This is only maybe slightly interesting, so we'll walk through that code when we get it here, which is somewhere. Oh, yeah, I'm in the wrong place altogether. Okay, so we need code Igor utilities and the log. So log is not that special. We'll look at it. Basically, we can set different log levels. It handles both file and console debugging. So like when we go to a final release of something, we can set them differently. So the file only shows important things, and the console, or the file shows everything, and the console only shows minimal things. We have some convenience methods for timers, blah, blah, blah. And then the main reason I keep these sorts of special loggers around is because of these push, pop, and top. I can log information and increase an indent, so I can print out structural or hierarchical data, or call trees with push and pop and top. So pop prints out, and then indent moves the indent in. Top doesn't change the indent, so that's not that interesting. But utilities uses it, and utilities can do a couple of things. We're mostly interested in entering a directory. So we'll tell it where to run these commands from, and then we can say execute a command, and it'll print a whole bunch of stuff to the file and some useful things out to the console. Okay, whatever. And then blah, blah, blah. Then it prints out the entire results of the output of that command. That's not as helpful as this one will be. I call it checkexecute. It executes the command, takes the text, so this chunk literally, right here, we're using it. Except we check to see what's inside the text, and we determine if we pass or fail based on whether it contains that text or contains all of some text or any of a list of options. Anyway, so these are the workhorses we're going to use. So in our test permutations, import log from utilities, import utilities. Easy. Okay. Start compile. It's going to be interesting. So let's set up some variables here. Compiler equals a thing. We'll build the whole thing with debug flags. we're not going to do release flags. And pound defines, we have basic flags, so warn everything, warn extra, no missing field initializers, and we're doing the 17 C++ 17 standard for now, and we'll be pedantic and debug. There we go. So there's our flags. The list of objects. All right. Quote, search for .o space delete. Oh, nuts. It messed it up. Why did it mess it up? F3, search for .o. I would like to keep it under 120 if I can. That's equals. Objects plus equals. Boom. So there's our objects. You know, we could do this in a slightly more Pythonic way, huh? Probably not a bad idea. Okay, new plan. We're gonna make this a list of strings. Put search for .o, delete, quote, comma, return. Boom. Compiler flags, objects. This we need our output. Basically what's it going to be called. Output the executable. Now when we build an object, it's very simple. It's just a simple pattern. We go through compile command. Let's see here, compile object command. Okay. So here's what we're going to do. We're going to take the compiler flags. Compiler's flags are the defines, which is the other thing we need. here. We'll pass those in as we go. I guess that's it. You know what? We don't have to do this here. We'll do it all in one place. Okay, so we're going to compile all of our objects. We're going to do the final compile looks like. Oh, that's a different thing. Another command. This is gen tokenizer. We'll come back to the directory later. Modulus s -p test vv project. Okay, so we're gonna, oops. This will eventually become some kind of a number. vv project -o source. Okay, so we're going to compile these objects. Then we're going to build something like this. So command compile vv. Let's see here. Python formatting dictionary. I think it's just with. I don't want that. I think I know what to do. Let's see here. Run Python. We can just test it real quick, make sure it is. Modulus name s modulus id modulus name s. In this case, instead of a tuple, you give it a dictionary name, which is thing, and ID is 13. Yeah, so it's parentheses. Because I never remember if it's parentheses or curly braces, but I'm pretty sure that will not work. This is private. Flags. Compile the object. This is the defines and the file. Compiler. Flags. Defines main, and then we need the objects -o. So I need source dir, right? Source directory equals a thing. Give it full qualified names. So just find that real quick. Source. There it is. This is a source directory. We need our destination directory. /builds/debug. Let's see here, and then we need a place to dump a temporary couple of files. Project file and a tokenizer definition file. This will be temp.vv.project and temp.vtoke. Destination dir. Tester equals basically this. So we can actually simplify a little bit. Which means we need OS. Import OS. This is actually from the source directory where we get the builds. Project file and the tokenizer definition file will be relative to the test directory. Phew. Okay, I think that's all the information we need to start automating this stuff away. Travest. Good afternoon, Mr. California. How are you today? I'm good. I'm good, but I'm not in California. I don't live in California. I don't know if there's anyone that can pay me enough to live in California. How are you doing today? Okay, so thinking through the process. So if we look at our make file, when we run a test through make, we first do a full debug build, which is basically that. It's called build. Embed. Oh, I forgot the embed step. We do need to embed the code snippets. Oh, yeah. We only need to do that once per test. This is a command to embed our code snippets. from our tools directory, which we should already be in. Well, let's get our tools dir. Might as well just have everything ready to go, right? Okay, so a build begins with, we're going to go into our tools, embed, cd source, build objects, build vv. Then we have to do the actual configure, which I think we've already got lined out here. Config tokenizer, build the test. There are several steps here that we have to do. Not too bad though. Sorry, my mistake. I'm doing good as well. It's late evening web dev here. Oh no, it's fine. I don't mind you not knowing where I live. It's one of those things. Feel free to guess. I'll probably let it slip someday, if I haven't already. But I will tell you this: you are on the right side of the country. So that cuts it in half for you. Okay, here's where utilities comes in handy. Utilities. Dot. Enter a directory. We're going to the tools dir. So every command we execute on the system level, it's going to happen inside the tools directory for now. Then we're going to run that embed command. And we want to make sure of is that we check execute this command looking for some happy output. So let's go to our shell, cd.hash. Let's just run a clean and build. Of course not. And what we're looking for is rote. It needs to succeed with both. We want that one. Needs to write both the header and the implementation file. Utilities, check execute. Check mode is utilities dot check. I think all, right? Check dot contains all. So if the output of this command does not contain, must contain both of these pieces. It must contain all of these things. That's what the check execute command is doing for us. Okay, so there's the embed step. Now we go into the source directory. And we build the object. So let's just test our script up to this point. Oh, let's see, cd tools. Oh, we aren't running that command. Let's just run compile. overbuild. It's not actually doing anything, so it doesn't matter what the output is. We could make utilities verbose. Utilities.verbose equals true. I think log.verbose has to be true as well for both of them to sync up and be happy. It's been a while. So we enter a directory, vv.tools. We call Python embed code snippets, and that did indeed succeed. And that. So we can test by putting something false in here. It must contain X. Just so you can see what we're talking about. Boom. It did not succeed. Contains all this false. So what we want to do is say we want a status. We want to say result equals true. Result equals result and that thing. So what this does enter dir doesn't return anything. It does not return anything. Simplify that code now. That's nice. Which probably means it could be done here. Note verbose pattern. Yeah, nothing different there. Perfect. That is besides the point. Change directory, target directory, blah blah blah. No fee. Okay, so we're gonna enter a directory. So if our result is ever false, like if check execute fails, then result becomes false. And the next time we do a result and, it'll hit false and it'll say, oh, I don't need to execute the rest of this. So we can actually short circuit the rest of the processing this way. So build objects. I guess we need a list of object files, object names, objects. For in objects, we're going to run the file object command. Utilities.checkexecute this thing. We will need the compiler, the flags, the build. Maybe we just call that defines here. Then the file, which is the object. And we want it to contain the text, scratch, shell. No. Compilation. There we go. Well, every time we build one of these, it should just succeed. So if something fails, let's say that the first object doesn't exist. First of all, this one should fail. Result equals result and utility to execute. So it should contain what? This doesn't need to contain anything, really, because utilities.py, when we execute, it'll process an error and fail. So that should be fine. That still returns the result. Oh. And it will fail it. Okay. Let's just take that for a quick test drive, see if the flow is as we expect. It does not contain that text, so we can fix that one. Otherwise, it won't go past the next step. Okay. So in our source directory, and format requires a mapping. Oh, well, yeah, of course. It's just me forgetting what I was doing over here. Compiler flags defines and I forgot the name. File. Is our object. Curly brace. Whoa. Who decided that? That is a very strange place to put that. There we go. Good heavens. Okay. Oh. Unrecognized command line option. Okay, so this is join all the flags. Defines, I think, are already joined. There we go. No such file or directory. Compilation terminated. Therefore, it fails on this command. So here's our command, g++ all extra, blah, 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 defines, and this xlog is what's causing us a problem. Xlog cpp no such file. Okay, so that's failing as expected. We go back up to xlog. It shouldn't work. Check faults. Linker input file not found. What? Defines. Oh, defines are not. Yeah, okay. We're not actually passing the defines correctly. We'll break out. So here. Take that build and a list of all objects and compile it. Okay, it did one. Enter directory. Blah 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 -C, and then what does an error contain? It contains warning or error, probably. So let's make an error. Let's go to our other log file, our C file. Source log dot. Fine. We're just gonna make it invalid. If I remember right, well, it's fine. It's fine. Contains error or warning. Okay. So let's go to our test file. So when we execute this command, we want it to not contain warning or error. We're going to check that it contains none. I think that's what it's called. There we go. Cool. So it's building all of those with the new flags. And we don't have to be quite so verbose if we don't want to, but it's fine. Actually, let's do log.set file log level equals log level dot all. Set console log level to usually go to like note. Compose. Then we should open a log file. Set log file. Yep. Test permutations.log. Easy. I don't remember, does log have a verbose defined in it? Verbose. If log.verbose. Okay, so we do have to keep track of that ourselves. That's fine. Okay, easy. So now everything logged at note or above, we should get to the console. All to the log file. Let's see here. Result equals true. Result equals result and compile. If not, result break. Seems okay. Okay. So now we don't actually need this verbose. It's going to log everything to the file. Except for errors. ASDF does not name a type. Okay, so this build, let's go up to compile. The defines are not joined. Are they? Not append. Objects. Do better snippets. Actually, do that before those. So that comes out of there. Enter our source directory. Compiler flags defines the object. Something does not name a type. -c b log cpp for error does not name a type. Oh, ASDF because log. However, not gonna lie. Oh, if not results, break. So why is it not breaking? Why is it not breaking? Oh, compile. No. For each object in our objects. Check the verbose log file. So here we go. We said we're going into tools. We embed the code snippets. We embedded them. They seem fine. Check that it contains all of those texts, and it's true. We go into. I'm going to go quiet my children down in just a moment. Sheesh. Okay. Late evening web dev here. Yep. Sounds good. Sounds good. Project progressing nicely. I know it's early days on a bigger project, so maybe it's still too early to tell. Sometimes you know pretty early, though. Okay, so we are running this command. Text generator, all the flags. That all looks correct to me. Log.h.c. Okay, so that's fine. But then it shouldn't be continuing. Like this result should be false because error is in the output. Contains none. Result true. That doesn't make any sense. Why is the result true? contains none. For t, so if we're checking, the result defaults to true unless we can prove it's not true. For t in check value, if t is in text, result is false and break. In text. Text. We're piping standard error to standard out. So the output, which I'm printing right here, right? Because we output, we decode it as UTF-8, and then we print it here. That output, so this output, which contains the keyword error, it should contain none. Because this returns result. So that text is returned. Chexecute gets that text. And check mode contains none. If t is in text, false and break. Huh. That's just not cool. Print text. Print t. Print fail. Error. What is that? What is it doing? Error. Okay, well, the fact of the matter is, execute. All right, let's try this then. Result with result text. Result flag equals false. Text and result equals that. If result. So only if the command succeeds do we check anything else. Okay, now it's at least failing, and test permutations log file should show that error thing. Yeah, just fails and dies. Okay, cool. Thank goodness. Test permutations not log. Let's see here. Utilities. Print. We don't need that. We don't need that. We don't need that. Okay. So if we fix that so that log.h.cpp is valid, then it should crank through all those build steps. which we should log out for our own following purposes. Oh, and there are 40 of these, so we don't want to keep going forever. Yeah. So let's do some logging. File log dot note. Compile. Given our defines. For now, just do before.o, which is the name of the object. Just so we can track it. We'll break after the first full permutation. So it should build all the object files. Build what? Oh, but we're not on trace. I have to build a trace level for that to work. Huh. Objects. Interesting. I want to time things as well, but that's slightly separate issue. Build and build permutations. Oh, come on. Oh, goodness. Result and utilities to execute. Not sure about this. Why? One, two, three, four, five. Oh. Okay. over quote, backwards for a quote. Only difference is we'll do it this way, just for fun. Build permutations. All right, build our permutations. Compile. So this is not. This is our defines. There we go. So seriously though, why is that not logging? Let's just do this. Let's just do log note. Note. Um, 107. Oh, it's this print that is happening. Oops. Build permutations. Result equals an empty list. Result plus equals. Oh, result equals. Array of arrays. Defines. Okay. What is this actually returning then? Print result. Oh, for Pete's sake. Okay, there it goes. Finally, stop. Get off. Get off. Oh, this is annoying. Okay, so that's returning what I thought it was returning. That's good. For each set of defines in our build permutations, we compile the defines and the list of objects. Defines is a list. That does return the result. What's going on here? It returns a list of strings here. File defines. Oh, I'm out of donut. We have to go get some more donuts. This isn't even supposed to be the hard part here. Fed code snippets. Fine. We'll just break here. Boom. Local variable result reference before assignment. Where? Oh. Oh yeah. Result equal. Actually, just turn it. Result equals. What? Build permutations. Oh. I know what's going on. Dot append. This is what we should be doing. I see what's going on now. There it is. And now we run it. There we go. One thing we should do first, early, we should do it clean and then embed. So let's go to embed code snippets. Push, pop, pop. Yep. One more time. Let's see what's going on here. What is going on? Why? It's still not outputting anything. Why not? I have used this stuff before. Trace is 5. Push. Push. So greater than equal to trace. Build up the message. Then we write at the trace level. And set dot up. There's the thing. It's printing out there. So is there a file only? If it's verbose, it's console only. Log dot verbose. Then to the file only, we write out a lot more detail and the result, then go back to both logging. That all seems okay. It's almost like it went into file only mode, never came back out. Yeah. Except that shouldn't be possible. Okay, so ooh, yeah, that's not good. These are function calls. What are we doing? All of a sudden it'll work. Yay. So we start up by embedding our code snippets, then we compile that combination of preprocessor commands. And there's the object files. Compile push. Top. And then pop. Oh. There we go. Okay, compile. Objects. Now, when we're doing this, we have these other build steps we need to do. So keep that formatting nicely this way. And still show all the steps. Okay. And we can always just do that to not show quite so many details. Now, build vv. We have a command for that. We already built it up. Build the command build vv. Result equals result and utilities dot execute our command. I don't remember what that command looks like. VV. So we need compiler, we need flags, we need the defines, we need the objects. Defines list. We're going to use those again here. So this command needs compiler. Let's try to use flags equals this thing. Okay. Build VV. Okay, so we need compiler, flags, and defines. Those are all the same. We don't have any libraries for linking. Main, so objects, destination directory, and our output file name. Let's see. Compiler flags defined. So the objects will be our objects. O for O in objects plus dot O. Objects destination directory, destination dir. We can find somewhere as well as our output. Okay. We're looking again for warnings and errors. So our destination directory, our output, and dest dir. There we go. Okay. One other thing we should do. Pre-build. We're just gonna call this pre-build. We're going to enter the source directory, and we are going to utilities.chexecute make HK clean, and I would expect it to contain something like .o in there. If the command itself fails, it'll fail out anyways, so that's fine. So we're going to enter the source directory. We're going to execute a clean, and pop out. Then we'll go to the tools directory, and oh, well, we could leave there. We're not really being very careful about that, are we? So we're going to execute, clean, then leave the directory, enter a directory. Turn result. Okay. So we're going to clean, embed snippets, then pop it out. Then we're going to build proper. All right, check this out. Okay. We are awful close. So let's see here. Test permutations 139. Compiler flags defines objects destination directory output. We're looking for errors and warnings, and it better not contain any. Modulus O. Where did we do that? Oh, I see where it is. This one. This modulus needs an S right there. There's a full clean, full build error. Oh. Object files. vv executable. Stick them all together. This This might seem a little bit tedious and not very much fun, and maybe we could use some existing build system, but honestly, I like having control of my own stuff, and it can do what I want it to do when I want it to do it. I don't have to fight somebody else's abstractions. So, then this will save us tons of time in the future as I make code. So, configure our tokenizer. Configure. Let's see here. Generate tokenizer. Build vv test parser. Which is not implemented yet. Will and run test. All right, we're getting there. Configure our tokenizer. We're going to enter our what project directory? Oh, when do we enter directories? Enter directory, source directory. We never leave it. We're about to, right here. Leave the directory. Generate our tokenizer. Want to enter our test directory. Going to re-enter our source directory. Then leave it. Enter our destination directory and then leave it. Okay. So we need to emit our temporary file. vv. So generate that thing. That is the command. Or something like it. Output executable temp whatever. This is not a big file. This is not a hard file. Easy peasy. Okay, first we need to output this. Let's look at test.vv project. Oh, I don't have it open. vv project. going to look a lot like this. Right as text, and then it's out. UTF-8, ASCII, and Latin 1 are 3 possibles. So we're going to dump that file out. This is the only thing that needs to change. That's UTF-8, depending on what we've selected in our defines. Okay. Our project file tells us our encoding, our name. It's going to eventually get more things like how we intend to use it, whether it's going to be like multi-threaded batch processing, blah, 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 blah. And try to provide reasonable default or reasonable interface methods generating based on those. But we're starting simple here. So what I'm looking for is what? I have to know which encoding is being used. Oh. Oh goodness, this is actually worse than this is terrible. Okay. Encoding. Yeah, we need to UTF-8. These are the 3. Yep, okay. Oh yeah. There we go. We need to define our encoding. Except that's not quite right, is it? It's not a define. So it is back to 120 build combinations. This is why we have to automate this. There's just so many things. Okay, def encodings. These are not defs though. So they don't have to be in that same loop. They have to be here. Or encoding in encodings. Compile encoding defines an objects. Encoding and the list of builds. Okay, we're gonna open that file and do that with now. This gets the encoding that's being passed in. We have to give it a file that we can use. Now, test.vtoke, line white space comment. I'm fine with all of those. Those are simple enough. Int is fine. String is very useful. Then name. Yeah, token ID is fine. Step 1. File.write. There's going to be issues with all of this. So backslash, backslash. We have to escape all our backslashes. That's part 1. Part 2, we escape our quotes, because that's easy to do. Okay. Okay. Some syntax or something like it. Now, if our encoding is one thing, we're going to do something. Encodings are these 3. That's actually a pass. In ASCII, we don't have to test anything weird. But Latin 1 we will, and UTF-8 we will. UTF-8, okay. So for Latin 1, we just need to pick a good Latin 1 character. I always like upside down question mark. It looks distinctive enough. Latin 1 encoding for upside down question mark. Oh, come on. Latin 1. ISO 8859-1. Oh, they give it to you in pictures. Catalan. Code page layout. Okay. So A1. What's A1 in octal? So go programmer calculator. Hex, we go A1 to octal is 241. 241. And then the upside down question mark is BF. Oh, we can do fractions too. Oh, we can do a few different things. We can do, yeah, there's a couple of good useful ones in here. We'll do a question mark, upside down question mark though. Get our Spanish people here having BF. BF is octal 277. Can I copy those out of there and have them rendered correctly here? Not there, here. That's the wrong question mark. I want this one. Then I want this thing. Hope that all gets encoded the way I hope it does. 1/4 is BC. BC is octal 274. Through, actually, 274 through 277? Yeah, we'll do it that way. Backslash 274 through 277. That's what that means. All right, for UTF-8, we're just going to steal the Russian code, the Russian piece here, or the Cyrillic, I guess it's. There, that's basically it. If we're doing ASCII, we don't do anything weird. If it's Latin 1, we have to add a few characters outside of the standard 7-bit ASCII range. And if it's UTF-8, we just add, some Russian letters or something, and the Cyrillic, and it'll be fine. Okay. So that will output a tokenizer file. And then run this thing. Equals result and utilities execute this command which needs output. I think that's it. Not actually much to that command. We can leave that directory. So this is going to write these out, write this out, and then generate our tokenizer, and leave the directory. So still nothing too crazy, and we're still bailing after the first loop. Yep. Okay. So now we're embedding it as ASCII. Oh, well, that's fine. Error is not recognized as an internal or external command, blah, blah, blah. So let's see, I'm trying to run modulus output s.exe. That's not being resolved the way I'd hoped. Probably because it should be something like this. Check the use. Oh, it doesn't have a value. Okay. So when we did that, oh, we didn't. Okay. What outputs do we expect? Oh, we expect these two files, right? Who does contain all? This one. Yeah, so same sort of thing here. Okay. Execute the list of this and the CPP version. And that. And it must be utilities check contains all. Getting further and further along. What? Okay. Just take that out. I said run as shell, right? In utilities, shell equals true. So it should treat it like a shell command, but apparently that's too hard for life. Source is not recognized as an internal or external command. I didn't tell it to. I said run this command dash P is telling it where to go for the project file dash O to get the source directory. That should not be executed. That's an argument. Source is not recognized as an internal or external command. I didn't tell that. Why is life so hard? Why does it treat me thus? Okay. This command runs fine. Runs fine. Why does it think source is not recognized as a command? It shouldn't be. It's an argument to the same darn thing. Come on, Python. there was an important difference at some point. Oh, that time it worked. Okay. ASCII Latin 1 does the same thing. Generate the tokenizer. Error. Dumping a stack trace. Okay, so let's take Latin 1 out of the listing for now. Over to UTF-8. Also dumping. Cat. That's your cat. Temp.v toke. It looks like it's, well, it shouldn't be a dump outputting that. 241, 277 through 274 through 277. Okay, that kind of makes sense, but let's put that one back in, because the issue is happening here where I'm outputting text. And it's text. Interestingly, we can save ourselves a lot of compiles if we do this right. So Latin technically works, UTF-8 fails as well. Charming can't map encode character in position 16, character maps to undefined. That's because here's our Russian. So temp.vtoke. All right. Is it U for UTF-8 encoding? Python UTF-8 encoded string. Oh, there's like a U prefix or something. U in Python 2. In Python 3, all strings are Unicode. Well, Unicode, I want UTF-8. All right, so in utilities, we do a decode UTF-8. Decode UTF-8. Oh, that was fine. Let's go remove ASCII and Latin 1. Let's just see if UTF-8 works. Okay. So that does Python decode Latin 1? Just try it as is. Believe we can maybe make it work. ASCII. No, not ASCII. I want ASCII back. We just want to try Latin 1. Okay, so that works. As long as we tell it how to decode things, it seems to be okay. Okay. Now we're going to move encoding. That does not belong here. It does not belong here. I know better now. It belongs here. For each encoding and encodings, so what this does is we emit these files and generate our tokenizer files. Then we can build just that test piece, then run that test piece. But we only have to build the objects. You only have to build vv one time for every 3 encodings. So it actually cuts down our compile time quite a lot. So let's compile. I actually kind of want to move this chunk into execute. Okay. Result equals result and execute. I guess the same defines. Actually, these defines don't have to be defined here at all. Compile doesn't need the defines. And the execute does. Does this argue for an awful lot less compiling than I thought? Yeah, this doesn't need the defines. This one does. This is the one that actually needs them. Okay, so the defines actually just go away. Do we have any pound defines we want to preserve? I don't see any. Dash D, no. No, I think we're good. Right, so compile vv, execute. Right, we need to change things just a little bit. This is compile vv, result and compile test given our defines, and then execute test. That's what it should be. Compile test given the defines. Which involves us generating our tokenizer with the output of the compile vv above, then build it, then run it. Okay. Well, then build. The test function will itself get a little bit more hairy, so yeah. Execute test. Okay, we're getting there. Hey, no C++ here? There is almost always C++. Today we're writing a Python script to automate testing 120 permutations of pound define that we're working with. Like 99% of the time it's going to be C++, but today Python, because the testing of our output is a little bit complicated. So let me give you a little bit of brief overview here. This is not the way to write code for production. This is for me to write for fun. Every time I come to a choice where it may affect the executable performance, I just make a pound define and implement it every which way I can think of. So we have system open calls, library open calls, and the file handling calls, and then obviously the C++ file streaming operators. So that way I can compare and say, how long does changing the build between these three options, how long does each of those take? How much does it cost me to make those choices? I have some intuition about that from past processes, but past projects, but I would like a number, a measurement. Same thing for iteration. Do I find an actual iterator class, or is it faster to just keep kind of track of the index myself and not worry about an iterator object? How am I dispatching my DFA statement? So anyways, there's all these different permutations and combinations which combine to make something like this, where, are we dispatching on function pointers? Are we dispatching on a switch statement or a function pointer array? So these pound defines, for me to be able to test all the permutations of that is a pain. So that's why we're into Python today. But again, like that's not normal. We'll finish up our Python today and probably not spend too much more time on it since it will do the testing of permutations we want. I should put Python in my tags, I guess. I usually don't, but today is a Python kind of day. Oh, I did it twice. There we go. Done. Boom. Yeah, so there you go. That's the explanation. Build the test executable. Pretty sure we have a command for that. Generate the tokenizer. Oh. Make file. We need to steal the other build rule here, which is this one. command to compile the test. Compiler flags or defines. This is the one where we need the defines. This one and this one do not need those flags, but this one does. And this one. Ooh, okay. Compile test part 1. Compile test part 2. I guess that's basically we just need that one extra object file. Test.cpp. I guess test.cpp is okay. Except I'm gonna have to do one last pound define, I think. This one cares about the encoding. Test encoding. Okay. Not sure why we're doing and here. What should be that? Oh, we do it in a few places. Good heavens, who can't keep track of which language they're in here? Shame on me. Utilities dot execute. I think for the build, all we do is check for warnings and errors, that those are not in there. Continue. Check warnings and errors. Right, so in our source directory, we compile the object for our newly generated vv test parser file. Looking for warnings and errors. This is the first time we really need these defines. So, oh, we need the flags. I guess that's fine. That's okay. Okay. Build the test executable. All right, we need compiler, flags, We need defines. That's it. Our flags defines. We will need the encoding for this one as well. Okay. Compiler. Okay, so we can steal compiler and flags here. Compiler and flags defines. Yeah. It's just the defines. Okay. The encoding is our encoding dot upper. I think it's upper, yeah. So Latin 1, UTF-8, and ASCII are the encodings, which will be embedded in the stuff. So that'll build our test executable in theory. Let's go take a look at those build commands real quick. So our log file will already have been built somewhere else, and that's fine. We build this one object file and this one executable with one special encoding flag log.o. Okay. Sounds good. Ooh. Where's our destination directory? Okay, so then our test exe equals our destination directory combined with vv.test.parser.exe. Okay. Ooh. Compile test, execute test needs to actually happen here. Because this build is the one that goes over the three encodings. Compile and run test. And execute test. Phew, okay. Which won't do anything, but it's fine. Equals our test dir, I think. And then we'll just run it, which is our test.exe, which we'll get right to. So let's run that. It should compile out. Oof, let's see just how much we messed things up. So we're compiling vv. Okay, local variable result reference before assignment. One of these 6. Really, this is the first thing, so it doesn't mean that. Okay, generate the tokenizer unsported character format, 196. Command compile test 1. That needs an S, that needs an S. Good heavens. Oh, wow. That's terrifying. Why is it dumping that file to the console? Error. And file included from test parser C expected identifier before a token. This is not very readable. So VV test parser is broken. Are we? Oh, generate tokenizer. So let's see here. Utilities.py. We want to do this in 2 pieces. File only, then console only, which will get a shorter version, a truncated version. Output from, I don't know, 256 characters worth. Then logged out both outputs again. Just so that the console doesn't get clogged. Okay, so it's cleaned up the old project, embedded the code snippets, compiling VV objects, compile the executable, generate a tokenizer based on ASCII, and then build the test executable, which doesn't work. Stir object has no attribute decode. This permutations dot 5 182. No, did we not test that? We tested that. Do I have to cast it to bytes first? Or do we encode? Wait, what am I doing? Why is it getting here in the first place? We're in ASCII. Generate tokenizer for Latin 1. Okay, okay. So this is, okay, all right. That is legitimate. Bytes. Okay, so we generate tokenizer ASCII, we build the executable, which does the command look right to me? Blah, 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 blah. Test parser.cpp. Test parser.h. Literally include nothing. What? Okay. So these are wrong. This is not helpful at all. Yeah, parse those like garbage. What's going on? It did not. It does not. It cannot. Okay, well, at least this makes sense in why it's exploding. I don't know what's causing it to output that text, though, that explodes. Bum, bum. vv.exe. Yep. Without putting the letters \n. Oh, well, then that's fine in this case, but we need the new line. So where's my test permutations? Out file dot write. Oh, here we are. We're just not going to read anything correctly if we don't output it correctly. We may have to. There we go. Maybe that will help. Function return. Const char value. text buffer define line. We can ignore that warning for now, but there's something else going on here. Decode, what? What is wrong with this Latin 1 nonsense here? Oh, well, we went back to bytes, so let's take the bytes out. Just decode the string. That was working once. Then we'll look at that warning. Nope. Right argument must be string, not bytes. I could swear I had to do something here. Or not. Yeah, Charmap can't encode those characters. That's Russian. So we got through Latin 1. Well, we did not get through Latin 1. It's stack don't. Build test executable. Which fails. We go Latin, which fails. We build UTF. Okay, so they're all not happy. Let's just start with one. Let's just do the UTF-8. Or the ASCII. I need a donut. I do not have enough donuts in my life right now. Okay, so vv test parser, line 305. Type qualifiers. But value is a char. What on earth? Value .305 const. Oh. Okay. That's fine. We can fix that. Assets, code snippets, char reference for ASCII, value, not need const. I see. That makes sense. Char reference Latin 1. Probably the same issue. Okay. Re-embed these code snippets, recompile everything. See if we can get through ASCII. Let's see here. Text buffer define line. .5. Oops. Char ref ASCII. Char ref Latin 1. Fourteen snippets. Code snippets we left. VV tools. Now we're going to compile VV by entering source. Huh. Generate tokenizer, build test executable. Oh, what's going on? I'm gonna grab donut. Oops. Grabbing a donut. Be back soon. See you in just a minute. This won't take long. Okay, audio back on. Removing note. Recenter. And back to it. Okay, so what is actually happening here? I told it to re-embed the code snippets. I should have cleaned everything old. I feel like I'm close, but I'm not sure what I'm doing wrong. So let me look at that log file, I guess. We go to our source directory, we clean it. sure it contains basically this thing as an indicator that it actually ran. Walk out of source, we embed the code snippets by first jumping into tools, then running that. Leave tools, whereupon we compile vv. But it's like that code snippets is not being updated. So let me look at my directory and see if there's a different directory nearby which contains an extra copy of files that it shouldn't. Code snippets 345. Feed into tools, run that. Huh. Then we compile vv, enter directory, object files, worked fine, code snippets. That's going to just make a whole bunch of file commands. Then put error code 1 bytes code UTF-8. What if that will more or less work? Oh, what's sorting the lines better? Remember function something int test parser, which doesn't help me at all, but at least now it lines up. Okay, but this problem looks to me this is for ASCII. It's no offset, byte offset. That's fine. It should be character offset. So byte offset happens at line 6.6. Okay. Const char value. See, but this is ASCII. That should not be there. Okay, all right. Code snippets. Ref ASCII. Value. See? This has no const in front of it. And this one, I believe, is for Latin 1 character reference. It doesn't have a constant in front of it. So where do we get a constant char value? We don't. It does not exist in our code snippets, which means what? What does it mean? It means vv test parser is not being written out. So let's, or not, at least not written out where we expect it to. Let me just rename vv test parser. And vv I don't want to run this from make. I want to run it from the shell and have it more or less work. We'll just rename this file. And it did output new ones. 359, correct. But this const should not be here. Because where that comes from, right, character reference, right here. It's the place where it gets, it says, hey, if we're doing ASCII, we output this thing. Which is at index 4. So code snippets.cpp 0, 1, 2, 3, 4. That aligns with the name at least. This is it for ASCII. Where's value? Value. There's no const char value here. It's taking this text, putting it in that file, but this is incorrect. So what is my thing even doing? You know what? Clean and test. I should not have to do this through make. I should be able to do it from Python just fine. Char ref. This is probably UTF-8. And value. UTF-8. Where is it getting this? Okay. It isn't in here. Const char value. Const char value. Oh, it doesn't exist there anymore. Okay. Clean. So now it's not complaining about the same thing. Now it's complaining about the right thing? Okay, so text buffer, where we define a line where byte offset. So right now the problem is ASCII and Latin don't need a byte offset, they just use a character offset. We can use character offset here just fine, right? Okay. Let's try character offset, character offset. So in ASCII, we don't define byte offset and character offset because a byte is the same as a character. Only in UTF-8 are they different. Text buffer define line. Is clean not doing anything? I now have my suspicions that maybe pre-build. We enter our source directory, make dash clean. Result equals false. Just to short it out here. Boom, cleaning. Star.o. You all seem to be gone. So it did clean. But what if we delete code snippets? And then we short our execution. Okay, we've got new code snippets. And we read from disk. If we look at our text buff, or define line, there we go. Define. These say character offset. Then why define line? Why is int define line? Why did that not update? So code snippets are updating correctly. vv test parser, if we remove those two files, and then run it, oh, well, that's shorting out. Oh. Okay, well, that's shorting. So test permutations high. Let's not short out the run. If we have no existing code snippets and no existing vv test parser, okay. Where is it getting this value from? Where's that value from? Make it verbose. Contains all is true. So when we run this command, it is writing out an all new vv test parser CPP file. What is going on? Clean removes the stuff. Running that does emit a new file. And the, okay, so let's just check code snippets real fast. Yes. Reload. Int define line, which is the pass-through one, and this one does not check byte offset. The only place that byte offset actually happens now is in string ref. Oh, that's kind of interesting. Oh, that's UTF. Oh, this is, I see. That's fine. Int define line. This one does not look for byte offset. Text buffer define line. That's no member named byte. That should not be putting that text in that file. Clean. What does this thing think it's doing? Why? Why won't it embed the right text? All right. Well, why don't we do this instead? In a permutations, clean. In our source directory, remove everything that looks like that. Let's go not verbose. Enter the source directory. Execute that. So, RM, RF, whatever, check contains. Yeah, it's a silent on success. That's a little bit sad. What? Why? Why is it doing this? We're defining a line as being between two characters, but I removed byte offset from that function. There's no other definition of that function. Root code snippets. That is the thing we're looking for. And they both have to have been true for it to continue. That's a completely different problem. Okay, well, we have an overflow problem. We test parser 1482. Okay. I actually agree. Therefore, that happens in the pattern to string, pattern to NFA. NBSP. However, only add this character if the encoding allows it. Now, who runs that? Tokenizer definition. The project. Parse a file encoding pattern to vv tokenizer definition. Tokenizer definition needs to know what we're supporting. Really, it's a tokenizer definition. Is that the only one that cares? When we parse the project. This is why we test. Project has the encoding definition. Well. Compile. Okay. You have like a global thing or anywhere? This encoding is inconvenient. It's not generally accessible. Hmm. Fine. Anyone cares is this one. Tokenizer definition thing. I hate doing that, but we'll do it for now. Then vv tokenizer definition p parses the other phase, and at this point, this compile needs a rule, or we could set its pattern to an ethical converter. Okay. Tokenizer definition. We will steal the encoding again. Into this. No, we're just gonna set it. Right before we parse out the NFA, right there. Set encoding. Set cast as a pattern. Okay, converter encoding. Yeah, I don't really like this. We'll add a to-do list to clean this up. Tech debt. PV project. PV tokenizer definition and pattern to NFA converter all have an encoding. Move the definition somewhere. Okay, but we're just gonna pack this together. Encoding. Okay, but now in pattern to epic converter NBSP if n_encoding equals UTF-8. Then we add that. Okay. File. Clean and debug. We'll see how that goes. Expecting a semicolon. I guess that's fair. Okay. Now we see if it compiles with ASCII or not. Or Latin 1. There shouldn't be overflowing conversion from some value to another value. This parser, 1482. That should not be there. 1492. I mean, 1482. Yeah, that \s, even though we're ASCII, I invert my logic. If the encoding equals this, like there's no other. There it is. There's another one. Because check it here. 100% NBSP. There we go. But that's a world of good. All right, I've got about half an hour left. Oh, come on. I'm not convinced that this Python script is actually overwriting files that should be overwritten. NBSP 1482. Why is that not there? Why is my Python script not? Doesn't seem to be updating the things that should be updated. See, that's a different error. It's somewhere else. 1501. Zero less than current less than 9. What's it complaining about? Member function operand types are char and charref. Oh, interesting. Okay, so we're not overloading the we actually want that back. Okay, so this is a good thing. Char ref UTF-8 operator equals, not equals, equals less than this. Char ref ASCII needs something like this. As does ref Latin 1. Why I have to make clean build before the Python script will properly embed the new Latin or ASCII stuff, I do not understand. I'd very much like to know. Something is missing. Ugh. I thought we'd be a bit further along. What? And it didn't take. It did not take. $15.04, huh? $15.04. And it's saying no match for character reference and character. But I just overloaded that. Operator less than equal to. It's right there inside this same exact class. It's right here. It's in VV test parser. All right, time for bed. You have a good one. We'll see you next week. Get some good rest. Have a nice, calm, relaxing weekend. Less than or equal to. Less than equal to. Operand types are. Oh. Hold on. Char ref. Put ASCII. Equals. Not equals equals not equals. Yeah, we don't have any of the greater than less than's defined. Well, we really need this one. This needs to be a bar. Character reference Latin 1. It was the other less than equal to symbol that wasn't being defined. This is a problem when you test only one encoding for too long. And now it's going to be very silly and insist that we do something to remake for some reason. Unclear why. We'll have to figure that out. Maybe it's too much sugar. Maybe I'm just sugar combed out here. Maybe that's why this is taking longer than I thought. Hey! Character reference has no C string. That I could believe. Const char star. Oh, wow, we don't have it defined anywhere. Good heavens, okay. C string. After the invalid reason string. Oh. For value. This C string is actually much easier. Instead of byte count, it's character count. Char offset, char count, blah blah blah, blah blah blah. I think char offset. We don't have a char count. We have what, a length? Where's our? Oh, it doesn't have a length. That's why. Char count. Result equals 2 bytes. It's always 2 bytes. No, it's not. Two bytes. Result at 0 equals buffer contents indexed here. That's it. We can short a whole bunch of trouble that way. We just copy the byte and this will terminate it. Same thing for lad. Ay, ay, ay. Maybe it's just the clean operation that needs to be done. I'll have to see. Maybe we'll try that on the next iteration here. It looks like the clean does everything I told it to. It looks like code snippets does everything I told it to, but hey, it worked for ASCII. Hooray. I mean, it's test permutations. We aren't actually doing a test, but it did build it. And return. Let's build all 3. And see how that goes. So rebuilds VV. Now it goes ASCII. Latin 1 still busted. Right argument must be string, not bytes. $184. Oh. But that's not Latin 1. Charm up can't encode character. Encode Latin 1. TF8 0 1 2 0 1 2. Our encoding is ASCII. We don't have to do anything to it. It's Latin 1. If it's UTF-8. 1. Dot encode Latin 1. Oh, wow. That almost kind of worked. Could not parse token, only found 2 out of 3 things. So something's broken there. Okay. It wrote it. So let's see what temp.vtoke looks like. Line, white space, comment, int, string, token ID. Oh. Just permutations. Why is it so hard to just write bytes of data here? Okay. What about this then? We just put the characters right in there. We don't encode anything, we don't decode anything. Ugh. Yeah, charm app can't handle a character. It shouldn't be there anyways. This is not the right line. This should not be a thing yet. This is for UTF-8. We aren't at UTF-8 yet. Bytes to string. Python, write a Latin 1 string to file. Surely. Your data is written down as UTF-8, which does not accept the characters I want because that's fine. To debug, take a look at print s.encode. want to use dash U. Well, I shouldn't have to. I don't want my editor to be doing anything to my text. I'm giving it the escape codes. This is what I want. That. Encode Latin 1. All right, come on, Python. Python string containing Latin 1. Let's see here. I have an error message for that. So it's charmap can't encode character. And somebody will tell me to call it encode. So I replace this code with that code with open. Oh, I have to give it. Oh, maybe. Maybe then we don't have to do the encode here. Maybe I have to do it when I open it. Encoding equals. The encoding we passed in, but the encoding we passed in is not going to be happy. Coding map. Actually, I really wish this stuff would just kind of work. I would like to, oh, maybe. Why don't we open that file as write binary? Then we can do encoding. Dot encoding Latin 1. Then it should be happy taking over bytes, right? ETF 8. Maybe. Well, you can even encode the ASCII. That's fine. Oh, no, it's g. This is bytes. If there was like a function call that just used a name. Oh. Not this one. This one. String object has no attribute encoding. So is it decode or encode? Okay. Now it's just Latin 1. It's stack dumping, but it did build. Well, it UTF-8 is working and ASCII is working as far as the build process goes. Yeah. All right. Gotta figure out what's wrong with the Latin 1. Coding in Latin 1. Which I think means we aren't even using. Yeah. So it should just be the Latin 1 version. And it fails, but we have the command here. Okay, there it's dumping. So gdb args run reduce cardinality segfault. Oh, interesting. Line something. $343. Huh. Latin 1. Okay, 5 more minutes. $343. Fragments is a list of fragments. reduce. The scan pattern says it was successful. Result was true. Result equals false. Result equals false. Result equals false. Result equals true. There's only 3 error cases within that string. Warning, not a problem. Temp.v token. I don't see a reason why that shouldn't work, but if we just take that out, it works. So it has something specifically to do with that. What if we take out the range? Still fails. So for some reason, syntax oh.
Nothing.
I bet we're walking through with a UTF-8 character when we're parsing those patterns. Which doesn't work. However, why that doesn't fail earlier, I don't know. So if we go like this, yeah, done by stack trace, doesn't matter. The problem is probably when we hit this character here. This is how we're walking through the pattern. Compile. Blah blah blah. Scan the pattern. Part. This. Nope. Well, yeah, it's. Shoot. This thing is checking against UTF-8 rules as it walks through, but if we have a Latin 1 encoding, that won't work. When we advance, we're going to get a 1, 0 for those characters, and why that doesn't print out an error, I'm not sure. Probably because this class is not up to date with the best UTF-8 processing we have. We have an invalid. As long as it's valid. Okay, so if we hit the end of this, return result. Okay, So we know what the problem is, I think. UTF-8 is a proper subset of UTF-8, so it's working okay. But Latin does not work with UTF-8. So that's got to go on our to-do list. Tech debt. Latin 1 is not a proper subset of UTF-8. So pattern to NFA converter is to take that into account. Okay, so we have a couple of items to do then next week inside the pattern to NFA converter. I need to walk through that string differently depending on what encoding we choose, which honestly is not that well. It either causes an awful lot of duplicated. Well, oh no, this is going to be sad. Okay, we're gonna have to think about that. I'm gonna think about that over the week. We'll work on it next weekend. But I've got to get going, so thanks for joining, everybody. Have a wonderful evening, have a wonderful weekend, and I'll see you on Monday back to game development. Have a good one. Bye-bye.